In this video, we will introduce ideas related to angle measurements and how we define the trigonometric functions. Now, in general, angles are commonly measured in one of two ways, using either degrees or radians. However, in calculus, we will use radians whenever possible. And the key relationship that pi radians is equal to 180 degrees allows us to easily convert between radians and degrees. So for example, let's go ahead and convert 225 degrees into radians. So we start off with 225 degrees, and to put it into radians, what we need to do is multiply it by pi, and this would be pi radians per 180 degrees. Then in terms of units, we can think of the degrees as canceling, and we'll just be left with radians. And 225 divided by 180 is 5/4. So this would be 5/4 pi, and this is now measured in radians. Now, equally, we can also convert from radians and degrees. So if we start off with 7 pi over 6 radians, what we need to do in a very similar fashion here is now multiply this by 180 degrees per pi radians. So the pi's cancel. 180 divided by 6 is equal to 30, and 30 times 7 is 210. So 7 pi over 6 radians is 210 degrees. Let's now look at how we define the trigonometric functions. We define the two basic trig functions, cosine and sine, in terms of the unit circle. So we're starting off here with, in blue, the circle of radius 1 centered at the origin. And if we let theta represent an angle measured going from the positive x-axis in that counterclockwise direction, then the point of intersection with that ray with the unit circle has coordinates cosine theta, sine theta. And let me just make the observation that this is exactly the same way that you may have seen it defined in the past in terms of right triangles. Because now if we go ahead and complete a right triangle that we see in the picture, and if I blow this up a little bit, because we are on the unit circle, the length of the hypotenuse is 1. Because this upper right-hand point has components cosine theta, sine theta, we know that the length of this bottom leg is cosine theta, and the right leg is sine theta. And now it follows that if you think about the angle theta, that cosine theta is really going to be adjacent over hypotenuse, and that sine theta is really opposite over hypotenuse. Additionally, once you have defined the trig functions sine and cosine, the definition of the other 4 trig functions follow accordingly. Now, one thing that we need to be very familiar and also very efficient with is evaluating these trig functions sine and cosine at common angles around the unit circle. And by common angles, I'm thinking if we're in the first quadrant, you would have 0 radians, pi over 6 radians, pi over 4, pi over 3, pi over 2, and you can also have multiples going around the unit circle. And the picture of the unit circle to the left here should be a good reference for values throughout the unit circle. And remember, if you're looking at a specific point, say pi over 6, the first coordinate is cosine pi over 6, the second coordinate is sine of pi over 6. And some very familiar things to remember is that when you're in the first quadrant, sine and cosine are both positive. In the second quadrant, cosine is negative, sine is positive. The third quadrant, they're both negative. The fourth quadrant, cosine is positive, sine is negative. So as long as you remember the symmetries associated with the unit circle and the values of cosine and sine at these important angles, you can get the other values at these common angles around the unit circle. So let's look at some examples that do this. So let's find the exact value of the following quantities. So first, tangent of pi over 3. Well, tangent is sine over cosine, so this would be sine of pi over 3 divided by cosine pi over 3. Sine pi over 3 is root 3 over 2, while cosine pi over 3 is 1/2, and this ratio ends up being square root of 3. Secant of 3 pi over 4 is 1 over cosine of 3 pi over 4. Now to determine the value of cosine 3 pi over 4, I'm just going to draw a simple picture. We're going to have the top half of the unit circle. So 3 pi over 4 would be this angle here. So that's really 135 degrees, or 3 pi over 4 radians, which leaves this leftover angle as being pi over 4. So we want to know what is the x-coordinate of this point, because the coordinates of the point will be cosine 3 pi over 4, comma sine 3 pi over 4. And by symmetry of the unit circle and thinking about this reference angle, the pi over 4, what we have is that cosine of 3 pi over 4 is going to be negative, and it's going to be the opposite of cosine of pi over 4. So minus 1 over square root 2. So back to the originally asked question, secant of 3 pi over 4 is 1 over cosine 3 pi over 4, which is 1 over minus 1 over root 2. And recall, dividing by a fraction is multiplying by its reciprocal. So minus root over 2. So lastly, let's determine the value of sine of 5 pi over 6. And once again, we are going to draw a picture of the top half of the unit circle. So we think top half of the unit circle, 5 pi over 6 would be about here. And this leftover reference angle is just pi over 6. And once again, if we think of the coordinates of this point, it's going to be cosine 5 pi over 6, comma sine 5 pi over 6. And sine 5 pi over 6 is the value that we are interested in. And if we think of symmetry of the unit circle, sine of 5 pi over 6 is going to be positive, and it is going to have the same value as sine of pi over 6. And sine of pi over 6 is a common value, which is 1/2. So sine of 5 pi over 6 we've determined by using symmetry of the unit circle is the value of 1/2.